Welcome to Click for IB Biology. We're studying D4.3 climate change, and in this particular video, we're looking at the effects of the increased solubility of carbon dioxide in our oceans, resulting in ocean acidification. There's a PDF of this presentation linked into the description. You can download that and annotate with your own notes. But then there's also a quiz. It's a 10-question quiz with answers, and you can use that to evaluate your learning here. So let's take a look at the coral bleaching, which is a consequence of ocean acidification. And you recall from the first video that we're estimating that around 20% of the extra carbon dioxide produced by the anthropogenic effects of human beings is being absorbed by the ocean. But if we've got more carbon dioxide, then that will lead to increased solubility of that carbon dioxide, but will lead to a decrease in the pH, which of course is acidic. Now, the particular impact here is that this acidification of the oceans shifts this particular last stage of this equation towards this direction, reducing the carbonate levels of the ocean. And with reduced carbonate levels, then this in turn reduces the calcification process, the calcium carbonate process. I'll just write that down there, calcium carbonate. So we need the carbonate to form calcium carbonate, and the purpose of that is to form the protective exoskeletal calcium carbonate skeletons to much of the coral reef community. Now, the corals, of course, are in a symbiosis with cells which are capable of photosynthesis called zooxanthellae, and the lowered, if we just move this back, the lowered pH also results in the zooxanthellae exiting the corals, and the impact of this is to bring about what is known as coral bleaching. So in this particular image that you can see here, on the left hand side, there still remains the zooxanthellae with their photosynthetic capacity, and you can see around the image the suggestion that with its functioning as a producer, then this creates the lower tier, the biomass production, upon which things like food chains and food webs of the marine ecosystem can be built. But with the loss of the zooxanthellae because of the drop in the pH, so the pH drops, becomes more acidic, the zooxanthellae exit the chloral structures. The consequence is this phenomena here, which is known as bleaching, and so the natural colours of the coral reefs are lost, which is actually the loss of the zooxanthellae, and the corals begin to die. So this is an example of the impact of ocean acidification on the environment. It's predicted, if we go to Climate.gov, that this is a great source for students to exit. I'll try to leave a link directly in my description below, but this is a great site to look at all of the concepts that we've been discussing under climate change. But here we're looking at the question, how long until severe bleaching is an annual event? And we can see that the darker colours are within 5 to 6 years of our current time, given at the time of making of this video it's 2025. And so the prediction here is that in 5 to 10 years, many of these coral regions, you can see the darker colours causing significant impact and bleaching, and then in the more southerly regions that would significantly occur within the decades that follow due to ocean acidification. Strongly recommend this website. Still got some great stuff in there on the different topics, not just coral bleaching, ocean acidification, but on all aspects of climate change. Well worth a look. And so this leads us to our next video, which is to take a look at some of the strategies to mitigate the effects of global warming and climate change that are occurring. The playlist is on the right hand side, and of course subscribing to the channel, greatly appreciated in the center there. Thank you very much.